Aspheric geometries are incredibly important in today's lens designs, but analyzing the measurements can sometimes be slow and tedious and prone to errors. But today let's see how quickly we can do this in OmniSurf3D and how safely, in terms of getting the right numbers in the right places, we can do this. So I'm going to clear out OmniSurf3D so there is no cheating in the background. This is totally emptied out, and we are going to start with a measured data set and the drawing for this particular surface. Let's start a stopwatch and see just how fast this goes. If we start the stopwatch, I like to drag in my data first to see if the measurement looks realistic. It looks great, so we can now go to our settings. For geometry, I'm going to choose an Asphere. Let's open up the drawing to get the coefficients. Our coefficients are down here. I will copy those to the clipboard and drop them into a plain text editor just to get rid of any PDF formatting. So here's a curvature, paste that into OmniSurf3D. The conic, grab that, paste it in. The polynomial coefficients. By the way, if you hold down alternate, you can grab a rectangle in some editors. So our coefficients are entered. Let's use perpendicular residuals and maybe look at the total peak to valley, maybe ST. Some places call this SZ now. And how about RMS, SQ? Great, we have configured it. We are now analyzing our Asphere, and we are done in 56 seconds. Now that's 56 seconds with me talking along. You can actually go faster in real life. But what we've done in just 56 seconds is we've compared our measured data to the drawing. We can take the measured data set and see how the nominal geometry fits through that data. We suppress that to see this filtered surface, and now there are many, many more things we can do to explore these errors further. Check out our full-length video on Asphere analysis, but in the meantime, realize that OmniSurf3D makes aspheric analysis incredibly fast and incredibly easy. To find out more, check out digitalmetrology.com.